So moving away from linear first order differential equations, let's move on to Bernoulli differential equations. So a differential equation is said to be a Bernoulli differential equation if it is represented in the form dy dx plus p of x times y equals q of x times y to the power n, where n is not equal to 0 or n is not equal to 1. Now, if n is equal to 0 or n is equal to 1, then this differential equation reduces to a linear differential equation, and we already know how to deal with linear differential equations. Now, the focus in today's lesson is to consider solving Bernoulli differential equations. So this is a Bernoulli differential equation. So a Bernoulli differential equation is a differential equation which is given in the form dy dx plus p of x times y equals q of x times y to the power n, where n is not equal to 0 or n is not equal to 1. Now, to solve a Bernoulli differential equation, let's look at the steps we are going to follow. So the first is we need to represent the differential equation in the form dy dx plus p of x times y equals q of x times y to the power n. So first we need to represent the differential equation in this form, and then we are going to write down the expressions of p of x, q of x, and then n. And then next, we are also going to treat this differential equation as a non-exact differential equation so that we find the integrating factor. Now, the integrating factor here is going to be a function of x only. So that is mu of x equals e to the power the integral of 1 minus n times p of x dx. So this is the formula we are going to use to find the integrating factor. And then thirdly, what you are going to do is to solve for the general solution. So we solve for the general solution. So these are the three main steps we are going to follow as we solve a Bernoulli differential equation. Now, we are given our first example here. We are asked to solve the differential equation x squared times y prime equals x times y plus y cube. So let's try to solve this example together. So first we have the differential equation, which is x squared times y prime equals x times y plus y cube. And according to the steps we are following, we need to represent the differential equation in this form. So we can rewrite this differential equation as x squared times dy dx equals x times y plus y cube. Now, the first thing is we are going to divide through by x squared. So we divide through by x squared, and then we have dy dx equals x cancels one of the x's here, so we are left with y over x plus here we have y cube over x squared. Now the next thing we are going to do is we are going to transpose this term to the left hand side. So thus we have dy dx minus y over x. Now instead of writing y over x, we are simply going to write minus 1 over x times y equals 1 over x squared times y cube. Now you realize that this is in the form that we are looking out for. So we can have p of x to be equal to, that is negative, because the negative is affecting this. So you have negative 1 over x, and then you have q of x to be equal to, that is 1 over x squared, and then you have n to be equal to 3. So we are done with the first part. Now let's move on to the second part, or the second step. That is where we are going to find the integrating factor mu of x. So we have mu of x to be equal to the formula given, e to the power the integral of 1 minus n times p of x dx. Now this is equal to, we have e to the power the integral of 1 minus n is 3, so 1 minus 3 times p of x, that is negative 1 over x, so negative 1 over x dx. So this is equal to e to the power the integral of, this becomes negative 2 times negative 1 over x dx. Now negative cancels out negative, and then we are going to have 2 is a constant, so 2 goes outside. So we have we have e to the power 2 the integral of, we are left with 1 over x, so 1 over x dx, and then this becomes e to the power. So when you integrate 1 over x with respect to x, then you have ln of x, so we have 2 times ln of x, and then this can be written as e to the power ln of x squared. Therefore, if e to the power ln of x is equal to x, then e to the power ln of x squared is equal to x squared. That is from properties. So we are going to have mu x. We have mu x to be equal to x squared. So this is the integrating factor. Now the next thing we are going to do, which is the last step, we are going to solve for the general solution. Now the general solution is given by y to the power 1 minus n equals 1 over mu of x all times the integral of 1 minus n times q of x times mu x all dx plus c. So we have y to the power 1 minus 3 equals 1 over mu x is x squared, so 1 over x squared, all times we have the integral of 1 minus 3, so 1 minus 3 times q of x, which is 1 over x squared, so 1 over x squared, times mu of x, which is x squared, all dx plus c. So let's quickly rewrite this on the next page. So that's where we have y to the power 1 minus 3 equals 1 over x squared all times the integral of 1 minus n, we have n to be 3, so 1 minus 3 times q of x, which is 1 over x squared, times mu of x, which is x squared, all dx plus c. So this is going to be y to the power negative 2, that is equal to 1 over x squared times the integral of, now 1 minus 3 is negative 2, so we have negative 2 times x squared cancels out x squared, so we are left with only dx plus c. So next we can have 1 over y squared, and that is equal to 1 over x squared times, now this is a constant, so we can pull out the constant, so we have the integral, let's say 1 dx. We can simply write dx or 1 dx, it's actually the same thing. Now we are going to perform the integration. So we integrate 1 with respect to x, and then we have x. So that becomes x plus c. Now we are going to multiply 1 over x squared across. So that's going to be negative 2x over x squared plus c over x squared. So x cancels one of the x's, and then we have negative 2 over x plus c over x squared. So that is equal to 1 over y squared. Now at this point, let's try to find the LCM on the right hand side. So LCM between x and then x squared is x squared. So we have x squared divided by x, which is x, times negative 2, it becomes negative 2x, plus x squared divided by x squared is 1. 1 times c is c. So that is equal to 1 over y squared. Now at this point, we can flip both sides of the equation so that we have y squared equals x squared over negative 2x plus c. So we have this to be the general solution to the differential equation. Now if you want to make y stand alone, the best thing to do is to take the square roots of both sides of the equation. So this becomes, we have the square cancelling the square roots. You have y equals, this becomes plus or minus the square root of x squared divided by the square root of negative 2x plus c. Now you have the square cancelling the square root, so that this finally becomes plus or minus x divided by the square root of negative 2x plus c. So this is said to be the general solution of the differential equation, that is y equals plus or minus x over the square root of negative 2x plus c. Now let's move on to the next example. So in our next example, we are going to solve the differential equation y prime minus 2y equals the square root of y times cos x. So we have y prime minus 2y equals square root of y times cos x. Now we can rewrite this as dy dx minus 2y equals cos x times y to the power 1 over 2. Now you realize that this is in the form dy dx plus p of x times y equals q of x times y to the power n. Therefore we have p of x to be equal to negative 2. We have q of x to be equal to cos x, and then we have n to be equal to 1 over 2. So that is for the first step. The second step, we are going to find the integrating factor. So we have mu of x, which is the integrating factor, is equal to e to the power the integral of 1 minus n times p of x dx. So that is equal to, we have e to the power the integral of 1 minus n is 1 over 2, and then times p of x, which is negative 2 dx. So we have e to the power the integral of 1 minus 1 over 2 is 1 over 2 times negative 2. So 2 goes here once, 2 goes here once, we are left with negative 1. So that becomes negative 1 dx. Now if you should integrate negative 1 with respect to x, they are going to have negative x. Therefore we have this to be e to the power negative x. So that is the integrating factor. Next, we are going to move on to solve for the general solution of this differential equation. So we know the general solution is given by y to the power 1 minus n equals 1 over the integrating factor times the integral of 1 minus n times k of x times mu of x, or dx plus c. So let's substitute the expressions and the value of n in here. So we are going to have y exponent 1 minus n, so 1 minus 1 over 2 equals 1 over mu x is e to the power negative x times we have the integral of 1 minus 1 over 2 times we have k of x to be cos x, so times cos x, and then mu of x is e to the power negative x, or dx plus c. So on the left hand side we are going to have y to the power 1 over 2, that is equal to 1 over e to the power negative x becomes e to the power x, and then we have the integral of 1 minus 1 over 2 is 1 over 2. So this 1 over 2, which is a constant, comes outside. So we are going to have e to the power x divided by 2 times we have the integral of, we are left with e to the power negative x, and then cos x dx plus c. Now let's pull out this integral and then solve that. After that, we are going to substitute that into this expression. So solving the integral. So that's, we have the integral of e to the power negative x times cos x dx. Now we are going to do this by integration by parts. We are going to solve this by integration by parts. So with that, if you have the integral of u div, then we say that this is equal to u times v minus the integral of v times du. So first of all, we are going to let u be equal to e to the power negative x, and then we let div be equal to cos x dx. Now let's try to find the u. So we are going to differentiate u with respect to x. So first of all, we are going to differentiate the exponent. So when you differentiate negative x with respect to x, you have negative 1. So you are going to have negative 1 times e to the power negative x dx, because we differentiated with respect to x. And then for div, we are going to integrate that. So when you integrate cos x dx, you have sin x. So let's substitute the expressions in here using this formula. So we are going to have the integral of e to the power negative x cos x dx to be equal to u is e to the power negative x times v, which is sin x, minus the integral of v sin x times du. We have du to be negative e to the power negative x dx. So this becomes e to the power negative x times sin x, negative negative, plus the integral of e to the power negative x sin x dx. Now at this point, we still have the integral of e to the power negative x times sin x dx. So we are going to perform integration by parts the second time. So this time we have u to be equal to e to the power negative x, and then we have div to be equal to sin x dx. So as usual, we find the u, and that will be equal to negative e to the power negative x, and then we have v to be equal to Now when you integrate sine x with respect to x, then you have negative cos x. You have negative cos x. So we have this integral to be equal to, we have e to the power negative x sine x plus, we have our bracket. Now the bracket is going to contain the integral of this. So using this formula, we have u is e to the power negative x times v. We have v to be negative cos x. So we have negative cos x minus the integral of v, which is negative cos x, times du. We have du to be times negative e to the power negative x dx. So let's rewrite this. So we are going to have the integral of e to the power negative x cos x dx to be equal to e to the power negative x sine x plus, bracket open, we have negative e to the power negative x cos x. So negative e to the power negative x cos x, and then here we have negative, so it becomes positive, and then we have negative here, so it becomes negative the integral of cos x e to the power negative x dx. So minus the integral of e to the power negative x cos x dx. Now let's simplify it, write it in a more simplified way. So that's going to be e to the power negative x sine x minus e to the power negative x cos x minus the integral of e to the power negative x cos x dx. And don't forget that is equal to the integral of e to the power negative x cos x dx. Now at this point, you realize that these two terms are the same. Okay, so we can transpose this to the left hand side, and then negative becomes positive, so we are going to have twice of this. So that becomes 2 times the integral of e to the power negative x cos x dx equals e to the power negative x. So we can factor out e to the power negative x, and then we have in the bracket sine x minus cos x. So we divide through by 2, so that we have the integral of e to the power negative x cos x dx equals 1 over 2 times e to the power negative x into bracket sine x minus cos x. So this is the final output of the integral. So we are going to substitute this in the expression for the general solution. So we got to the point where we had y to the power 1 over 2 equals e to the power x over 2 times the integral plus c. So we are going to substitute the expression for the integral, in place of the integral. Okay, so we are going to have y to the power 1 over 2 equals e to the power x over 2 times, now in place of the integral you have 1 over 2 e to the power negative x into bracket sine x minus cos x plus c. So we are going to have e to the power x times e to the power negative x all times sine x minus cos x, and then we have 2 times 2, which is 4. So we have all this divided by 4 plus e to the power x over 2 times c becomes e to the power x c over 2. Now e to the power x and then e to the power negative x cancel each other. According to the laws of indices, this becomes e to the power x plus negative x. X minus x is 0. Any non-zero number raised to the power 0 is equal to 1. So they cancel each other. We have 1 times sine x minus cos x, which is still sine x minus cos x, all divided by 4 plus e to the power x times c over 2. Now at this point, let's try to find the LCM. Remember that on the left hand side, we still have y to the power 1 over 2, y to the power 1 over 2, y to the power 1 over 2. So that is equal to, we have LCM between 2 and 4 to be 4. 4 divided by 4 is 1. 1 times sine x minus cos x is still sine x minus cos x, plus 4 divided by 2 is 2. And then we have 2 times e exponent x times c. So at this point, we can let 2c be equal to c1, okay? And then we can express y to the power 1 over 2 as square root of y. So we have square root of y, and that is equal to sine x minus cos x plus e to the power x times c1, all divided by 4. And then we can express this as the square root of y equals 1 over 4 times sine x minus cos x plus e to the power x times c1. Now at this point, since we want to solve the differential equation in terms of y, we can square both sides of the equation. So we have square cancelling square roots. Therefore, we are going to have y to be equal to, now the square affects 1 and then 4. So we have 1 square to be 1 divided by 4 square to be 16. And then 1 over 16 times sine x minus cos x plus e to the power x times c1 all square. So this is said to be the general solution of the differential equation. So that's it for today's video. Thanks for watching and see you in my next video. Bye bye.